Hello everyone, my name is Chirag Patil and welcome back to my YouTube channel. So in today's video, we will understand what is transfer learning. So in previous video, we had implemented VGG, ResNet and AlexNet and InceptionNet using PyTorch, and we had also understand how to train that models, right? So now we will learn a very useful concept which called transfer learning. So let's get started. So first of all, what is transfer learning, right? So transfer learning is a machine learning technique where a model developed for a one task is reused as a starting point for a model on the second related task. Okay. So let me tell you first of all, if you train any model from the scratch, let's say you have one task image classification and you want to train a model for that. So first thing you will require a very large amount of label data. The second thing you will require is higher resources, right? You will require a GPU, right? And the knowledge also to tune the CNN. Okay, so there are 2 to 3 things which you would require to train a model from the scratch. Okay, so what if we can take advantage or use the model which is already trained on some images? Okay, so if you see VGGNet, ResNet, they are already trained on ImageNet dataset, right, which is a very large scale dataset and 1000 category, right? So that model basically know how to extract the features from the image and how to read the image basically, right? So we can utilize that knowledge to perform our downstream task. So this is basically a transfer learning, right? So if we see, let me show you the paper of AlexNet, which we will use as of now. So if you see any kind of convolutional neural network which are trained on the classification task, if you see VGGNet, ResNet, InceptionNet, AlexNet, right? So they have first layers are few convolutional blocks, right? Okay, so let's say in the AlexNet we have 5 convolutional block. In VGGNet we will have VGG19 we will have 16 convolutional block. So if you see in AlexNet, this part basically before this dense layers or linear layer, these convolution blocks work as a feature extractor, right? So these convolution blocks, the major task of these blocks is to extract the features from the image or learn the images, right? So later layer, this which are the linear layer, will use this feature and try to classify the image, right? So this part which contains a convolutional blocks are working as a feature extractor, right? So same in transfer learning, we have two concepts basically, fine tuning and feature extraction. So first let's understand what are the key concepts in transfer learning. So first is pre-trained model. So as I say, we will utilize the model which is already trained on generic task or related task on the larger dataset, right? So that model will know what are the information we need to extract from image, like age, shapes, color, etc., right? Now there are two major part of transfer learning. One is fine tuning and second is feature extraction. So let's understand first feature extraction. So if we see this diagram only, okay. So what we will do, we will use, let's say we are using AlexNet, okay. So we will use already pre-trained AlexNet. So our model knows the ImageNet dataset, right? And it is having good accuracy on ImageNet dataset, let's say. So now what we will do, now I want to train the model which is AlexNet on the cat versus dog, which we will use in this video, okay. So what I will do, I will use this part which has the convolutional blocks as a feature extractor, okay, and I will use this part as our classifier. So while I will train this model, I will freeze this layer. So these layers or convolutional blocks will not get trained. We will train only this part, okay. You can train only last layer as well, but let's say we are only training this classifier part, okay. So feature extractor will work by default or as it is which are used in the AlexNet, right? So that basically know what to extract, and then we will train only these layers which will learn how to classify into dog or cat. So features are extracted from here and this will work as a classifier. This is a simple transfer learning technique, right? Now second thing is, let me show you, second thing is fine tuning, right? So in fine tuning we will adjust some layer as well. In our case, let's say convolution layer as well, right? Not on the earlier layer but later layer. So if I see the same image, so let's suppose you have some different kind of data set, right? So first of all, let's say this model is AlexNet. It's trained on ImageNet data set, right? So, and you need to classify some cat versus dog or related images. So you know very well that these are the images which are related to ImageNet dataset, right? So model will know or understand it very well as a feature extractor layer, right? This part. But now let's say you want to classify some medical images, right? Which are not the part of this dataset or are far away from what this network is already trained, right? So what we will do, we will use few layers as it is, as we are doing in the transfer learning, but we can fine tune or we can update the weights of these layers which are near to the output layer. Okay, so let's say these two convolutional blocks I can update or I can train them. So first layer would be fixed or it could be the freeze layer, and these are the layers which will be trained. So this is called as a fine tuning. Okay, I hope it makes sense. There is a transfer learning and fine tuning. In transfer learning, we will use as a feature extractor and then train later dense layer or linear layers. In fine tuning, we will also tune a convolutional layer as well, or you can say the main block of that network as well, right? So why use the transfer learning? So first, it is already trained on the large data set. It knows how to understand the image and it will fast train, because if you see, as I mentioned, if we are using transfer learning, we are just training this part, right? This part will be as it is or it will be fixed, it will not train. We are just training these linear layers, so our learning parameter will be drastically reduced and it will learn faster, right? This is the first thing, we will get faster result. The second thing, less data will require, because our feature extractor already knows what are the features which we need to extract, right? So we do not require the larger data set when we are using transfer learning. Okay, and third, better performance, because it is already trained on larger data set, it will provide the better accuracy on our task as well, right? So this is the brief about transfer learning, and now let's implement it. Okay, so for implementation I am using the code from the previous video notebook as well, in which we are understanding how to train or test the model, right? So I am utilizing that code. So let me first write the data loader and dataset code. So I'm just importing few libraries. And one more thing, we will use the torch vision, and models will provide you pre-train the model, which are like VGG, AlexNet, ResNet, whichever model you want, you can find it out here. Okay, so we will utilize that. So let's create the data loader. So if you are not familiar with this code, I would highly recommend that you go back and check out the video in which we had used train and test, how to train and test the model, right? So now our data set is ready. So now let's write the code for the model, and also I am reutilizing the code which are training and testing part from the previous video, right? So let's say our model will be models.alexnet. Let's say pre-trained will be true. Okay, so pre-trained will be true, that means it will use the weight of pre-trained model, right? And now let's say model will be model to device. So I think I need to first provide the device as well, which I have written, right? So let's say device will be torch.device, it will be CUDA if torch.CUDA is available, right? Else it will be CPU. So now let's first create the model. Okay, so this is the ImageNet model which is already trained on ImageNet dataset, right? So what is AlexNet object has no attribute to device? Yeah, it should be only 2, not 2 device. Okay, so it's ready. So if I print the model, okay, so let's see what are the steps are there. So if you see, they had also already divided that into two parts, feature extractor or classifier, right? So this is the feature which use basically convolutional blocks, max pool and convolution, right? And classifier is another layer, which another model you can say, or block, which is having a linear layer, and last layer is number of classes, right? So what we will do, we will freeze this layer. We will not train this feature model, okay, this part. We will only train this part, right? Okay, so first of all, what we need to do, let's freeze this model. So for that we need to write, let's say, for parameter model dot features dot parameters, right? So basically I am using this model dot features, and dot parameters will return that each layers, right, or each parameter you can say. So let's say I just need to provide required grades is equal to false. So this layers will be not trained when I will train the model. Okay. The second thing we need to do is number of classes. So basically, if you see, the last layer has out feature is 1000, right? Because ImageNet dataset contain 1000 classification or 1000 class classification problem, right? But now what we have only two classes, cat and dog. So we will replace this layer. So I can write, let's say, model dot classifier. So we are accessing this, and if you see, we need to update or replace the sixth layer, right? 0 1 2 3 sixth layer. Basically it is the seventh layer, but index is 6. Okay, so we can write 6 is equal to, let's change it, nn dot linear, and it will receive the 4096, right? So it will be as it is, 4096, and number of classes, which is 2, right? Now let's update the model as well here, model dot to and divorce, right? Simple. So now we have a model which is Alex state, but we had freeze the layers which are in the feature block or convolutional blocks, right? So this part will be not trained. We will only train this part. We will use this part as a feature extractor. So this will be our model, right? So now rest part will be same as it is as the previous video. If you see, I just written the train loop. Okay, so we are just iterating over the batch size, and we are performing a backward propagation and loss calculation, right? So let me update this part. We will just print at end of the epoch. Okay, so it would be one tab, right. Let me remove this as well. We don't need any steps to follow. So just it will print accuracy and the loss for each epochs, right? So this will be our train model, and I also written the test function as well. So if you are not recalling this code, I would highly recommend just go and check the previous video in which I had explained each and every line. Okay, so now let's train the model. Okay, so if you see in that video, we had trained the model for 20 epochs, right? And at 20 epoch we receive a 90% accuracy. But as we are using here transfer learning, I will use just 2 epoch and you will see the magic. Okay, so let's run this. So it will take a few seconds to run one epoch. Okay, so till that I can show you the result of that from training the LXNet from the scratch. If you see, at the 20 epoch we received 90% accuracy. On the testing we received 93%, right? So now let's see what we get after transfer learning. Yeah, so the 2 epoch is trained. If you see, at the first epoch we receive 94% accuracy, and the second epoch we receive 98% accuracy, right? Which is phenomenal, because this data set is very simple, but you can compare these two techniques. One is training from the scratch, and second is using the transfer learning model, right? Now let's test the model. Yeah, so on the testing also you receive 98.50%, right? So you can see here it reduced our time drastically, right? And you do not require any kind of changes or tuning much, right? Because you are using transfer learning here, and it train very faster and you receive the very good accuracy. This accuracy you haven't received till 20 epoch as well, right? What you receive in the 2 epoch. So this is the usefulness of transfer learning, and this is used in very much in the industry as well, right? So this is all about the transfer learning. If you have any query or doubt, you can write in the comment section. We can discuss there. If you like my video, please press the like button and subscribe my channel for more content. Thank you.